Good day, my name is Christian Ace G. Bubis. I will be the one who shall present the following real-life applications of a hyperbola in a word problem. The presentation contains a given, illustration, complete solution, step-by-step, and lastly, a conclusion. So let us begin. The following presentation was brought to you by Team Beta. The presentation contains a word problem related to the conic section hyperbola. And here is the problem. Find the equation of the hyperbola that models the sides of the cooling tower. Assume that the center of the hyperbola, indicated by the intersection of a dashed perpendicular lines in the figure, is the origin of the coordinate plane. When you find your answer, you need to round your values into 4 decimal places, of course. Here's the solution. Assuming that the center of the tower is at the origin, we can use the standard form of a horizontal hyperbola centered at the origin. The standard form is x squared over a squared minus y squared over b squared equal 1, where the branches of the hyperbola form the sides of the cooling tower. But first, we must find what is a squared and b squared. First, we must try to find a squared. Remember that the length of the transverse axis of a hyperbola is 2a. So, 2a is equal to 40. Therefore, a is equal to 20. Divide both sides by 2. And if you square 20, it will become 400. And a squared is equal to 400. To solve for b squared, we must first find x squared and y squared using unknown points in the illustration. By looking at the figure or the illustration, if we were to use the top right corner or top left, we already have a designated x and y value. The value of y is 77.082 thousand and x is 70. To find b squared, we must isolate it from the horizontal hyperbola. We will use this for finding b squared. As provided, x squared over a squared minus y squared over b squared is equal to 1. We move y squared over b squared to the other side and we move 1 to the other. We switch them to different places. It will come out as x squared over a squared minus 1 to equal y squared over b squared. Cross multiply x squared over a squared minus 1 times b squared. You don't have to multiply, just separate it from the original one to equal y squared. Then divide both sides by x squared over a squared minus 1. It will become b squared equals y squared all over x squared over a squared minus 1. Since we have already isolated b squared and provided all the values needed, we solve for b squared. We substitute y with 77.082 raised to the power of 2 all over. Substitute x squared with 70 raised to the power of 2 and a squared with 400. It will come out as this. If we square 72.082, it will become 5,941.6347. And if we solve for 70 squared over 400, it will become 49 over 4. Lastly, if we minus 49 over 4 minus 1, it will become 45 over 4. Then we solve for 5,941.6,347 over or times 4 over 45. B square is equal to 528.1453. I've already rounded the original answer to the value of the fourth place. So, the answer will be x squared over 400 minus y squared over 528.1453 or 1453 equals 1. In conclusion, if we were to find the answer, we first had to locate the a and b values. When looking at the figure, we have to locate the transverse axis since it contains the a square value. After finding the value of a, we then locate the b value. In locating the b value, one must find the values of x and y. In conclusion, if we were to find the answer, we first had to locate the a and b values. When looking at the figure, we have to locate the transverse axis since it contains a square, which is 400. After finding the value of a, we then locate the b value. In locating the b value, one must find the values of x and y. By locating a known point of origin, which could be the top right corner or top left corner. Lastly, since x and y value is already given in the illustration, we can isolate b square so that we can solve and complete the needed values of a square and b square to form the horizontal hyperbola formula. Thanks for listening. The members of our group consisted of 5. Here we are. I am thankful for all my members in assisting and contributing to this presentation. This was made by Team Beta. I'll see you later.